Generally, people don't realize that data collection and preparation takes a lot of time. When we are in the industry, we generally spend 80% of our time building the data set and only 20% of the time utilizing it. This is generally surprising for many people because it is usually expected that the data set is generally easy to have and we spend 20% of our time to acquire it, clean it, and then we can spend the rest of the time to utilize it. But unfortunately, this is not the case. In the industry, generally, it's really costly, and we spend a lot of time having access to the data, cleaning it, and doing all the processing because the data is not so clean and it's generally difficult to access and especially not available in the shape that we want, etc. So it is advisable that if we go to the industry, we should consider and expect to spend a lot of time in the data preparation. Okay, so the different step here that we want to do when we prepare the data is we want to first ask where is our existing data. So if there is an existing data that we do not have the access to, maybe it will involve some legal negotiations to get that access because it can be some restricted data that may need some paperwork or some form of payment. Sometimes we need to perform anonymization because before we can use the existing data. So we need techniques to anonymize the data to make sure in case of a data breach, some level of confidentiality is still maintained. So there are different types of anonymization techniques. The minimum possible can be just removing the identifiers or removing the names of the people, but be aware that generally it's not sufficient to maintain the confidentiality. There have been many academic publications that have shown that it's easy to identify who the person is, even if we remove a person's name or any specific identifier linked to him or her. Generally, anonymizing data is not an easy task as what we are doing is removing some personal information like birthdays, names, etc. But sometimes we have to spend a lot of time to add some amount of noise in the data. So let's say that we remove the name, but the age of the person in combination with other features can allow to de-anonymize people. If we add some noise, example, adding few years or so in the age of the people, probably we can ensure some anonymization. Also, if we have some existing data that we have to spend um, uh, to some time in certain transformations of the data that is accepted to us. If we have some data in different format or if we require to merge different sources of data, etc. If we don't have existing data and we want to create a data set, then we have to understand that it may take a very long time and it can be really costly as well. But if we want to do we have to think of a way that can help us to collect some data. Example, we can use web scraping, but generally websites are not well designed, so it can take a lot of time. Usually there are a lot of errors inside the data, and we may need to change the way we scrape and relaunch again. It is advisable that the time spent in scraping is not underestimated. If we collect some data, we can also use some statistical sampling. So we will not go much in details, but it's basically the idea about observing only a small amount of people, a small sample inside the population. If we remember in the first lecture, we talked about the idea that to measure the average height of the people living in a country, we may not need the height of the entire population, but we may only need a small sample, maybe only 5 to 10% of the people of different age groups and ethnicities would be enough to give us an idea of what the average height of the people in that country is. We can use the available theory of statistical sampling to help us know how much confidence we can have when we do such a sampling. Another approach to collect data is to build surveys. There are different available options. Then we have to think about what we will label the data with different costs involved with it, and we have to think about all the processes that are associated with collecting the data. Maybe we will need to deploy a platform to present to the user the images that we want to the user input for classification, and probably repeat the process multiple times. For example, in case of Google, when we are filling a captcha, we are working for free for Google. For sure, they know some answers to make sure that we answered correctly, but for some images, when we are asked to click on images with a car in them or a stop sign, they just get user inputs from the people. And since they repeat the images multiple times for multiple users, it is done to ensure that they have consistent data. So we have to think about the way we will need to label the data. Next step is to clean the data, which is generally a tedious step and not necessarily fun, but a necessary step. Here we have to think about the domain validity of each for each feature. What is the range of value expected, and it can differ from feature to feature. It has to be done, especially in case of user input for data collection, because we can get invalid data from users. For example, if we ask the age of a user, we may receive an invalid input of 150 to 200 years. So we have to think of cleaning our data in order to use it. Also, we can think of removing outliers. So if we have some data points that are very far from each other, it is advised to remove those as it can affect a lot at the training part of our machine learning model. Although we have different algorithm in to detect outliers, but generally it's good to analyze them by ourselves. One preferred way is plotting our data to look for descriptive statistics. For example, if we see that the maximum value of a feature is very far away from the expected, then maybe it's good to remove it to avoid damaging the training part of our model. Also, we need to think of the errors, because sometimes we have errors in the data irrespective of the reason. So we need to check for erroneous data. Another thing to consider for checking is duplicated data. So think of checking if we have that too, because it can be bad for learning from that. Same goes for old and expired data. It will make it probably good to remove it, because if it's not valid anymore, it can harm the training phase of the model. Now, an optional step of data collection and preparation can be data augmentation. Data augmentation is the idea that we have some way that we can augment our data. We can have more data from the data that we have. So one classical application is in computer vision, for example, in image recognition. If we have images of cats and dogs, the model can be improved if we also give the same images but rotated. Randomly rotating the images to a certain range of angles can help the model to understand that even if we rotate an image of a cat, it still is a cat of an image. Same goes for the image mirroring. So we can mirror the image and can give it to the model as an additional example. Now, there are a few things that are advisable in both industrial and academic perspectives. Let's check them out. So, first, we need to think of reproducibility from the beginning. Reproducibility is when we are able to have the same result when we exactly do the same process. There can be times when we will extract some data and may need to rerun the data extraction process. Even if we think uh, that we will extract some data once and it will be the end of it, but generally that's not the case. The reasons can be plenty. Maybe we will need some additional features, or maybe there is some more error that we weren't aware of. Maybe we need to update the data. So think about the need to extract the same data again in the future. Another advice is to always check the raw data and the process data. So, if we are required to process some data, it is advisable to take some examples and check if what has been done was actually required. So, for example, if we only need to apply spam filtering on non empty emails, then maybe we can check the length of the content is greater than zero or more than a certain number. Take some examples from the database, from the raw data, and check if these are corresponding to the process data. The idea here is not to trust on our implementation. Always check to see if the values found are the values expected. Another advice is to keep backups of our data, both before processing and post processing. In case of a bug in our processing script, we should be able to rerun it using the backup of pre processed data. Another advice is not to assume that the data is valid. It's important to check that the data is good. This also includes checking the validity. An example can be the check of postal codes, especially in the case of user inputs. As we talked about it before, users can input fake data, for example, multiple nines. Another example that we discussed before is to check the validity of age so that invalid inputs such as 150 or 200 years can be avoided. It is also advisable to make sure to properly encode missing values. Sometimes people encode missing values by putting values like -1 or multiple nines and process accordingly to signify that this value is not a number. Special care is required to be taken to encode missing data in case of continuous values. Let's say we have a continuous variable and we left this value multiple nines to denote missing data. Then the model, instead of considering it as a missing value, may consider it as an actual continuous value because these values are not distinguishable. So we need to take care while encoding the missing values. All right. So there were some recommendations. Let's come back to the machine learning project lifecycle and see the next step in detail. So just to recap, we started to cover the machine learning project lifecycle and we talked about the business problem, the goal definition, and the data collection and preparation steps. Now that we have clean data, We want to make it usable to a machine learning model, and we want to train this model and to evaluate it. So, we will now cover these three steps in detail. Okay, now let's review the next step of the life cycle of a machine learning project, which is feature engineering.